design and construction project, from an engineering perspective, it's really important to understand the water balance, to understand where is the water supplied from and what is the demand, where are the water sources in the building. So the supply of water, you have potable water, but you can also look at how else we can get different sources of water. So you have condensate water, where you can capture the condensate from HVAC systems. You have rainwater, where you can capture the storm rainwater from outside and use it inside the building. And grey water, so recycling water from taps and showers and so on. And even black water in some cases, we recycle toilet water. And then we look at the demand. So cooling systems, for example, district cooling uses a lot of water. How can we make that system more efficient? And the fixtures and fittings installed within the building, how can we reduce flow rates to conserve water on the outside of the building, the landscaping, which I mentioned a bit before. So how can we use more native or drought-resistant species to reduce the water consumption there? So ideally, we want to close the loop. I mean, the ideal world is to have completely 100% water being recycled, but naturally with things like evaporation and so on, it always needs to be topped up. But the ideal world would be to reduce the potable water consumption as much as possible and look for alternative ways to reuse water within the building.
It's really incredible, the new developments. I mean, now you have, for instance, 1.5 liters per minute, all the new low flow urinals and sensors links and shower heads versus the standard ones which are 12 liters per minute. And also we were talking, Catherine, last time when we mentioned that around 70% of the water at home is used on the WCs and unused water, which is really, really interesting facts, you know.
Yeah, so having waterless urinals or moving towards waterless toilets are really important to reduce water consumption.
One thing I like to remember, water is meant to flow. Water quality, the way it's treated, particularly potable water, it gets some disinfectant, something to make sure that it doesn't grow microbes. The worst enemy for water quality is stagnation. We don't want potable water to stay for a long time in the same place because it loses the chlorine, whatever you add to make sure it's microbiologically safe. So we want to make sure that things flow. So rivers, everything, water flows by definition. When you think of water, we usually think of flow. For the same reason, when we talk about fixtures, potable water, we want it to flow even a little bit when it needs to flow. Otherwise, we might lose the disinfectant. Design needs to be holistic in the sense of you can't just put like low flow in pipes that are not properly suited for that flow. Otherwise, you're going to have stagnant water that might lose the disinfectant. You might grow organisms like Legionella, for instance, when you take a hot shower and you're within risk. There's a chance that you might get Legionnaire's disease, which is actually, at least in the US, now one of the waterborne diseases that cause the most damage. It's one of the things that the more you look, the more you find. But it's something that can be engineered out. If you have good maintenance of your system and you design appropriately, you can design not only for sustainability, for what is called like more conservation, but also for safety. And true sustainability comes from both. I mean, you have to have some safety because cleaning or like repairing a building plumbing system is definitely more expensive and more resource consuming. The key is to keep the water flowing when it needs to flow. So let's design for less flow, but make sure it always there's a flow.